Hello friends, I'm Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering at AKGEC Engineering College, Ghaziabad. And today I'm going to discuss about double sideband with carrier, modulation index, power and efficiency of AM. All of us know that modulation is very important concept in communication for the transmission of signal. And amplitude modulation comes under continuous wave modulation, and it is further divided into double sideband full carrier, double sideband suppressed carrier, single sideband and vestigial sideband. So today we will be discussing about full carrier type of amplitude modulation and efficiency and power of all these equations. Now, double sideband with carrier. In amplitude modulation, the message M of t is impressed on the amplitude of the carrier signal C of t. We are having two signals, one is the message signal and other is the carrier signal. Two signals are there, the message and the carrier. Carrier will be carrying our message signal, and carrier is a very high frequency signal, and in amplitude modulation we will be changing the amplitude of the carrier according to the amplitude of the message signal. That's why the message signal is impressed on the amplitude of the carrier signal. This results in sinusoidal signal that is called modulated signal, whose amplitude is a function of message signal M of t. Now, the message signal can be considered as A of m cos omega mt, where AM is the peak of the baseband signal. It is called baseband because we are not, this is not the modulated one. That's why it is called the baseband signal. It has angular frequency omega m and frequency, modulating frequency Fm. In the case of carrier, the carrier has the peak amplitude A of c and its angular frequency is denoted by omega c and carrier frequency is denoted by Fc. The standard equation for an amplitude modulated wave, this is a single tone wave, that is given by S of t, that is the standard equation for modulated waveform, AC into 1 plus Ka m of t cos omega 2 ct. So here the amplitude of the carrier has been varied according to the message signal, where K is a constant called the amplitude sensitivity parameter of the modulator, and substituting the message signal by the message am cos omega mt, we can write down this equation as AC into 1 plus Ka and m of t, that is am cos omega mt, that is omega m is equal to omega m is equal to 2 pi fm of t, and after solving this equation we get AC 1 plus this Ka into Ma, that can be also K into Ma is called, denoted by mu, and it is called the modulation index or modulation factor. It is called modulation factor. So you can write down in terms of modulation factor, the signal has been in the amplitude modulation, the signal has been modulated. So this is denoted by mu. Now we will further solve this equation. When you further solve this equation, as per the definition of wave, we are required to change the amplitude of the carrier. So when we change the amplitude, the earlier equation AC into AM cos omega mt, when we will open this equation, then we will get two terms. One will be the carrier, that is AC cos omega ct, and another is the multiplication of the carrier and the message signal. Now if you further solve this equation by multiplying and dividing it by 2, then we will get, readjusting the equation, we get am by 2 into 2 cos omega mt plus cos omega ct. Now this is nothing but a trigonometric function, to cos a, 2 cos a, cos b. That can be written as cos a plus b into plus cos a minus b. So cos a plus b plus cos a minus b. At the same time we have multiplied it and divided this equation by AC. So further rearranging it, we can write it as am by AC into AC by 2, where am by AC has been replaced by m or mu, that is called the modulation index, and other equation will remain the same. Now the final equation of amplitude modulated or DSB carrier with or full carrier wave can be denoted with three parts, that is one, that is a carrier, another is omega c plus carrier plus message, and third is carrier minus message. So there are three terms. This is the carrier, this is the message, this is the upper sideband, and this one is the lower sideband. That is why it is called double sideband with carrier. Now you can see here, when I will be saying double sideband suppressed carrier, then the equation will contain only two terms. There will be no carrier term. And when we will be talking about single sideband modulation, then one of the sideband, that can be upper sideband or that can be lower sideband, can be removed, and we will be sending only one of the sidebands. There will be no carrier, so that will be called single sideband. Yeah. In the final equation, you can see this is the carrier term, AC cos omega 2c. This is the upper sideband and lower sideband. Most of you will say that the carrier is not being transmitted. No, this is not the case. The carrier is not being transmitted. This is not the case. We are transmitting carrier plus message signal, the frequency carrier plus message signal, and the carrier minus message signal in the case of suppressed carrier. When we talk about suppressed carrier, in that case also our carrier has been modulated, the amplitude of the carrier has been modulated, resulting in upper sideband and lower sideband. So all the information will be in the upper sideband or lower sideband. Now, if I want to see the frequency spectrum of this AM signal, this is the wave, this is the equation that I have got. Taking the Fourier transform, I am getting this equation, and ultimately if I am plotting it on the spectrum, on the x-axis we are having frequency, on the y-axis we are having the amplitude, then we are having on the we are having the carrier FC, and one is the upper sideband FC plus FM and another is the lower sideband FC minus FM, and the amplitude is AC by 2. The amplitude is given by AC by 2 in the case of these lower sideband and upper sideband. And according to this equation, this Fourier transform, you can see there will be mirror image minus FC plus FM, minus FC minus FM and minus FM. So this is the spectrum diagram of AM. Now, as we know, we have to, for communication, bandwidth is very important. So whichever type of modulation we are using, we have to calculate the bandwidth of that particular modulation technique. We know that the modulation, the bandwidth is given by the upper frequency minus lower frequency. Now, in the case of this AM modulation, the upper frequency is upper frequency of upper sideband and lower frequency is the frequency of lower sideband. And the upper sideband frequency is FC plus FM and the lower sideband frequency is FC minus FM. So, the total bandwidth will be FC plus FM minus FC plus FM, that will come out to be 2 FM. So, in the case of amplitude modulation with full carrier, the bandwidth is 2 FM. Therefore, bandwidth required for the transmission of FM signal is twice the modulating frequency. Now, the important term that we had discussed in the general equation of this double sideband full carrier is modulation index. It is very important to discuss about this modulation index. That was the ratio of AM by AC. Is defined as the parameter which determines the amount or depth of modulation. AM is defined as the measure of extent to which carrier voltage is varied by modulating signal. We had seen that modulation index is equal to AM by AC. Okay, that is AM is the amplitude of the modulating signal and AC is the peak amplitude of the carrier signal. It is defined as the measure of extent which a carrier voltage amplitude is varied by the modulating signal. It is the ratio of peak amplitude of the message to the peak amplitude of the carrier signal. It is also denoted by mu. In some books it is denoted by mu and in some books it is denoted by M, or it can be written as MA also. Any type of description can be there, or mu is equal to AM by AC, or mu is equal to K into M of T, maximum. Modulation index is the maximum value for message. For the message, the maximum value will be 1, M cos omega MT. The maximum value can be 1, so that can be 1, and ultimately it will be AM. M of T, that is equal to AM cos omega M of T, and this can have maximum value as 1. So that's why the maximum value of M of T, that will be maximum value of M of T will be A of M. That's why it is written as Ka M of T ka maximum, that is equal to KMT. So the modulation index, percentage of modulation index is equal to AM by AC into 100, that will give the percentage of modulation. Now we have all this is the modulated waveform in which the maximum amplitude is amplitude of carrier plus amplitude of modulating signal. So this is the maximum amplitude, this is the minimum amplitude, this is maximum, this is minimum. It is modulation index can also be written as A maximum minus A minimum upon A maximum plus A minimum, where this one is denoted as A max and this one is A minimum. So we are having A maximum and A minimum, and modulation index can also be written as A max minus A minimum upon A max plus A minimum, that is equal to AM by AC. Right, now modulation, according to the value of modulation index, we can have three types of modulation. Then is under modulation, there can be critical modulation or over modulation. When we will call under modulation? When the modulation index is less than 1, when the ideal modulation, when modulation index is equal to 1, and over modulation when modulation index is greater than 1. That will lead to distortion also, over modulation. Now we will be discussing about the power in the amplitude modulated signal. As we will be sending the message signal, modulating the message signal, we will be getting three terms, that is the carrier, the upper sideband and lower sideband, and then we have to discuss about the power of the amplitude modulation signal. So this is the equation that we have already discussed. So the total power of AM modulated wave is equal to power of carrier plus power of sidebands. As you can see, the three terms are there. This is carrier, this is upper sideband, and this is lower sideband. So the total power is equal to PC, carrier power, and power of sidebands. So the total power as whole of the signal is being transmitted, carrier as well as both the sidebands. So total power that is to be transmitted will be the summation of carrier power plus sidebands power. So power transmitted is equal to power carrier plus upper sideband plus lower sideband. Now power of carrier, that is the amplitude here is maximum peak amplitude is AC. Now the RMS value of this amplitude will be AC by under the root of 2, and we all know that power is given as V square upon R. Now here we are having RMS value. For this RMS value, we will be taking the peak divided by under the root of 2. So we will get AC by under the root of square upon 2, that is AC square upon 2R. So this is the power of the carrier. Now in upper side and lower sideband, there is a term called, this is a term here. So we will be taking AC into mu upon 2 under the root of 2 for the RMS value. Ultimately it will come out to be AC square. Solving this, we will get AC square into mu square upon 8R. So the total power will be addition of both these powers. So you can see here, total power is equal to AC square upon 2R plus AC square into mu square upon 8R. So this is the power of each sideband. So total power will be addition of carrier plus upper sideband plus lower sideband, that is given here. When we will solve this equation, ultimately we will get the equation of the power, the transmitted power, that is equal to power carrier into 1 plus mu square upon 2. This is the power that will be transmitted. So today we will discuss about the double sideband suppressed carrier, the equation for double sideband carrier. We will discuss about double sideband carrier. Then we discussed about modulation index, and then we discussed about the power of AM signal. In the next lecture, we will be discussing about some numericals on the basis of this power and modulation index. So this is the power in the carrier, the total power that is So this is the total power that is being transmitted, that is equal to cavity power into 1 plus mu square upon 2. Now coming to the efficiency of AM, the amount of useful message power present in AM is expressed in terms of transmission efficiency. As I have told you that we are transmitting the carrier, the upper sideband and lower sideband. Carrier itself contains no information, and when we talk about upper sideband and lower sideband, both are transmitting the same information. The same information is being transmitted in both of these. So efficiency will be calculated in terms of information, that when we are sending the important information, if we are sending 3 signals, but as carrier is containing no information, upper and lower sideband both are including the same information. So there is no need to send all of these. So when we talk about efficiency, it is the amount of useful message power present in AM that is to be calculated. Now it can be defined as the ratio of the power in the sidebands, that is equal to upper sideband plus lower sideband, because carrier is not considering any information, upon total power. So we have already talked about the power in the upper sideband and lower sideband. So we will add up both, and we know that the total power is given by this equation, and on solving this we will get the formula for efficiency eta, that is equal to m square upon 2 plus m square. So power in sideband upon total power into 100, that is the efficiency of amplitude modulated wave. So in the next classes we will be discussing about some numericals on the basis of this modulation index, efficiency, power. So I hope you will be able to understand the concept of double sideband, efficiency and power through this lecture. Thank you. Thank you all. These are my references. Thank you.